Hello guys, so in the previous video we went over fitting the Pearl curve. Again, this is a Pearl curve. This is the sales per capita and it is equal to L, sum L, that is the cumulative sales by time T. And we have 1 plus AE minus BT. Now, for last time I felt I probably didn't have a very organized overview of how A and B are affecting the curve. This is optional. It's just for your curiosity, because I have many smart and curious students in this course that may be asking questions about A and B and why do we need A and B and all that. So I found a very nice explanation, not only of this, but also when you have e to the power of e, as you can see here. So this is, it takes time to really explain to you in a very step-by-step order why these are done this way. So for this purpose, guys, for this purpose, I am going to link us on Moodle with this very nice explanation. It takes time, so only for curious students, maybe after final examinations, if you want, or toward the, because I'm not going to question you about this, all right? Make it clear, this is optional. But I have many curious students that they may be thinking, why do we need the A and the B? If you're asking this kind of questions and you would like to know more about the behavior of the functions in general, this function in general, the AB, the AEBX, this is a very important function in mathematics, as you can see. You want to know more about its behavior and how its behavior changes with the change of the domain or the change of the to the power of the E, then please visit this site, and this is not required or needed for a quiz 4. However, I felt maybe in the last video I just cut through many steps to just explain what I want to explain, and I was just afraid that maybe I couldn't show you exactly why, if you're still curious. But for some students, maybe my explanation was just satisfactory. Probably most of you. I hope so, I'm not sure. Let's see. I need to ask you so that my feelings are irrelevant here. Okay, so let's take a look, guys. All right, let's take a look. So over here, we need to estimate L, A, and B. So we need to find out for each year's cell phones per 100 people and what are the L, A, and B. So we are going to use Solver to find the values of these parameters, and that minimizes, of course, the sum of squared estimation errors, even though it is looking like a logistic regression. Why did I talk about logistic regression and why is it logistic regression? Let me just back off a little bit here. I told you that with logistic regression, y is equal to 1 and 0, or 0. 1 if, for example, x is greater than or equal to some threshold, and 0 otherwise. Okay, so this is this is how we define the y for logistic regression. So after that, we're going to end up with, so x will be actually so many values, and when it's greater than a certain threshold, it will become 1. So the output, the original output of the logistic regression is so many values between 1 and 0. Looks like a probability. So it's a probability that you belong to class 1 and the probability that you belong to class 0. And the main idea with logistic regression is how to find that threshold that tells you if your value or probability is 60% or above, or 62.3% and above, you are 1, belong to class 1, if not, you belong to class 0, and so on. And this is one of the beauty of machine learning algorithms. So with machine learning technique, we will be able to find out the algorithm through the confusion matrix and so on. So this is also a totally completely different story we teach in analytics classes. And it's a very nice one. So we end up with, for example, here 0 and here 1, right? And then we end up with so many values. If we sort the values that we have, so many values will be here 0, and then from this value onward, so many values will be 1, right? Yeah. And then what happens is, if you want to draw a curve, the curve will look like that, isn't it? Like an S curve, right? Right? It's going to look like that, something like this, to be clear and precise, right, guys? So it's going to be an S curve, and this is why we say logistic curve, because we will have a threshold here, and there are ones here, and then here like that there are zeros. Okay? So this is the similarity with the logistic regression and this. For your information, if we're not doing this online thing and we were progressing faster, I was the original plan was to work with logistic regression first. After linear regression, I wanted to give you logistic regression. As you can see here, I have all the material ready, so I don't want anybody to think that I am lazy or whatnot. No, guys, I have all my material ready, I have all my slides ready, and I have even more ready for you guys. And even, guys, I have another module ready, measuring the effectiveness of advertising. I never had the chance to cover it here, but maybe I'll cover it in the digital marketing course one day when we progress faster. So there's a lot to do with me, and I prepped more material for this course, but there is no time for logistic regression. I don't want to give you at the end of the course something that needs time, like linear regression. We took our time with linear regression, so you felt you understand it, satisfied somehow. If 70% satisfied, you understand 70% of it, this is good for me. So I am afraid to introduce this and you don't understand it as much, and I'm very quickly, and I stress you out, and it's difficult, and then bad emotions at the end of the semester. I don't want us to get bad emotions at the end of the semester. So if you are interested in knowing more about logistic regression, why don't you sign up into our circle, the programming and the business analytics circle, so that we can work together, yeah? And I can teach you logistic regression then. Doesn't matter the grade or the course, it matters if you want to really learn it. Why don't you join that circle, and in winter we can take it together. So I apologize that maybe you are a little bit, that don't exaggerate things. If you're in a bad mood today, please don't exaggerate. A little bit confused about logistic regression, logistic curve, and this curve. But I hope I was able to show you very quickly that this is ones and zeros and they are connected together, so it looks like an S curve. This is why we said logistic curve, because I can't just forget that there's a word here in the title called logistic curve and you don't know what it is, right? All right, lovelies. End of blah 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 blah. I talk too much, so bad habit. Okay, so over here is your file. I already prepped it for you, and I put here for you very nicely an image of the equation. So you always remember, this is the L, this is the A, and this is the B, yeah? And then over here, you have the number of year, here's the periods, So we have period 1 all the way to period 11, and here you have the years. And over here, you have the number of cell phones per 100. So it's a percentage. This is why I told you, lovelies, do you remember what I told you about even logistic regression? It is the numbers ranges from 0 to 1. It's like a probability. It's like a percentage. Yeah, a percentage is like a probability, isn't it? So over here, we are going to enter the formula. L, so over here, this is L. And then over. Okay, calm down. Over 1 plus. I like to also put these into brackets and put it E exponential. So we have exponential of minus B. Where is A? There is A here. A times. Okay? So L over 1 plus, in between the brackets, A times exponent of minus B times T. And T here is not this year, it is the period here, year 1. Okay, love? So this is the year as is, but this is the column that has the year. So if I give you the years in the quiz, I'm just going to give you the years like this. Be careful and smarter than me. I just want you to make sure that you are actually using the 1, 2, 3, 4. Okay? And now we are closing the red and we are closing the black. Ta-da! All zeros. Why is that so? Because we need to use the data, the solver, and then, but before that we need to, right? And then before that we need to also find the square error. Just like in linear regression, we would want the actual minus the predicted, all right? And then as you can see here, this is the sum of squared errors. So this will be the sum of all these squared errors. And if you don't know what this is, please study linear regression well. We talked about in linear regression, we talked about how this value over here, the actual, minus the predicted. All right? So this is the actual, and this is the predicted. All right? Good. And this is, we should put it as a squared error. So we should square it. So, so if you look at the solution here, so we put it here, this minus this is squared. So you need to square it, right? Because it's a squared error. So please do that, yeah? And then after you're doing that, let me do it then. It's just easy. Let me just do it very quickly. So let me do it here to the power of 2. So you please do it, square it, yeah? Square this error so that we don't have any negatives, right? Do you remember, guys? And then here's the sum. And now you need to set up solver. So please set up solver so as all these numbers, L to A to B, so from F to H, do you see, L to B, they're all greater than or equal to 0, and they are all less than or equal to 1000, let's say, a certain bounded number. 1000 is too big, really. I will just put 100, but I'm following the book. However, I feel like this is too big of a number, really. So over here, you can see he's putting it less than or equal 1000, and L is less than or equal to 200, and please make sure that you are minimizing what? You are minimizing this. So this is the objective function. We need to minimize the sum of squared errors. So minimize it by changing these values over here, and these values over here, you need to put all these and make unconstrained variables non-negative and use the GRG non-linear. Once you do that, let me just, you do it. I'll give you, of course, this video is maybe very short, 10 minutes, but this means it will take you about so you will take longer time to run it, and when you run it once or twice, and you will get this answer. So this will be the solution. All right. So once you get the solution like this, as you can see, I put it up to 11, right? 11 periods. So this is up to 11 periods. This is your solution up to 11 periods, as you can see here. So, and these are the right numbers that can calibrate the function. As you can see, it's in hundreds. So this is why I told you 1000 is too much. So how do you write the equation? The equation will be x of t, or x of t, not t. Sorry, this is a mistake here in this book. It should be x of t, right? He put for t equal, where is it? He put it somewhere here. Or maybe I made a mistake, maybe, not the book. No, I think the book, you see? Cell phones per 100 people during year t. I made a mistake. I should take the whole thing. So I should copy the whole thing. You can't just put t is equal. So it's my fault, not the book's fault. I should copy that and put it here. And then let's make it beautiful. And you, goodbye. So because it's x of t, right? Right, guys? It's x of t. Right, guys? So now the cell phones per 100 people during year t, which is x of t, you can also put it, is equal to L, 118.17. You can just keep it in 2 decimals, all right? So it should be 1.6 even. Okay, mine is 1.6, his is 1.7, and all variations is okay. And then 16 here, 1 plus 11 point, this is in 3 decimals, okay? 618 minus 619, e to the power of minus 31 minus 32. Actually 319. He had 319 like me, it's okay. Minus 0.319 t. Okay? So that is the function right now, the fitted function. Okay? Now, would like you to see here that these here, I was doing something fun. I did something fun. This is the end of the question, right? But the inflection point is the natural logarithm of a over b. So this is exactly the inflection point, which is 7.68. It is somewhere year 7. 1, 2, 3, 4, 5, 6, 7. At year 7.6. So the inflection point is somewhere here in the middle. Okay? So this will be here the inflection point. Yeah? Alright. So now, what's next? I would like to show you we are predicting the future. So let's say we have year 12, 13, 14. And we would like to predict that. So I basically just took the same values and just copied. Now I would like to see the predicted. This is the red one is the predicted, right? So over here, I'm gonna expand this, and let me expand also the years here. So over here, as you can see, this is the one in red. Let me show you. This is the cell phones per 100, and this is Pearl forecast. Look, this is the forecast, and it still looks awesome for an S-curve. Do you see that? We don't have the real values still, but it can forecast nicely for an S-curve. Okay? All right, so this is the end of the discussion for the Pearl curve. The idea of the Pearl curve is to find, for example, the number of products sold per 100 people during a certain year. Basically, the percentage of products here also could be done for a certain year, so that we can get the S-curve, and we need to fit the curve by finding L, A, and B through the solver. Thank you so much. I will give you 10 minutes to observe this. I would like you to retell yourself, re-explain it, put yourself in the shoes of a teacher. You're the teacher. Speak out loud. Speak out loud and explain the Pearl curve to somebody, and do it, and then please do the Excel, and I will see you in the next video, where we are going to talk about the next topic, which is fitting the S-curve with seasonality. So we're going to talk a little bit about time series analysis. I didn't have the chance to cover it because also it is covered in Stat 2. So we have a course that covers the time series analysis, but I'm going to talk to you a little bit about seasonality and how we are going to fit this curve with seasonality. I'll see you in the next video.